suppose from A to B, from a bank, if 10 rupees is detected, and T1 is will be the type of transaction which is going to be happen, and T2 obviously will have one transaction. If in the middle, if T2 is going to put 100 rupees to T1, okay, then if there is a power failure or something happens, then that T2 transaction which has been done to T1 of 100 rupees will not be updated. Okay, so in this case, what happened? The previous transaction, that is before the power failure, what is the transaction happened? That particular transaction data will be given to the or written as a data which has been which has to be given to the T2. Okay, so in that case the amount will be 90 rupees. So what we have to do is we have to do concurrency process, where at a fraction of second itself the data will be saved. So once the transaction is done, it will be committed again, commit or abort, so that the other next transaction will not be happened. Okay, so in that case the commit or abort transaction is done, then we will get the result as a 190. Okay, so we will see today we will see locking protocols. What are the different types of locking protocols, and how it's going to be useful for the transaction process between T1 and the T2. Okay, so locking protocols. So locking protocols is actually, it is associated with the data item. Okay, so this will come in a MCQ. Just make a note. Okay, it will come in a MCQ surely. Okay. So what is called variable associated. So each data will have been described in the particular statement. So it has to be given in the possible operation that can be applied. So what are the possible operations? So it has to be describe the status of the item. So, okay, so a lock, if a lock is going to be happen, it has to be describe the status of the item. So now the locking will have here two types of security measures, where the data can be, or a data item from a transaction can be happened. Okay, so using these two security measures, what are the two security measures? Permission to read and permission to write. Okay, these are the two security measures which can be gathered in a particular database. Now we can have here streamline of data, where the data will be read and written. Okay, so we will see a small example regarding this. So before moving to the next slide, we will see locking protocols. So locking protocols is a variable. So again we are having a small recap. What is locking? Locking is in a variable how it is associated with the data item. How it is associated with the data item. Next one, how it is describing the status of the item. Status in the sense, what is the possible operation that can be applied. Okay, there are a set of possible operations which can be applied, and it will be and the operation which will be secured in the locking process. Now it has two types of security measures which can be implemented. So that is permission to read, another one is permission to write. So whatever the data item for a transaction is going to be done based on this read write permissions. Okay, next step. Okay, so there are two types of items. Example, if there is item X, means we are going to lock the item, means, or unlock the item, means we will have a small method. So previously we have just locking using the read write, right? Next one, locking the particular item. Okay, if there is an item is there. Now I want to lock this item by using a particular transaction, and I have to, for that transaction I have to request that particular transaction where the locking process can be done. Okay, so for that one I will use lock of X. So this lock of X, what it will do? It will lock the particular item. Okay, so next one, unlocking. So unlocking will have a permission. So for that one, whatever the thing you are going to do, whether you have to lock or unlock, you have to get the request and the response. There is the permission from that particular data item. Then only you can remove the data or lock the data, whatever it is. Okay. So before that, you have to get the permission from that transaction to lock or unlock. Okay. So while unlocking, there are many transactions which is available. So all the transactions have lock and unlock that are atomic operations. So what is called atomic means it will lock automatically and unlock it. But before that we need a request. We have to send a request and the permission has to be received. Okay, once the permission is received, then you can make the operation as an atomic. Now, so conflict matrix. So here comes the conflict matrix. What is called conflict matrix? Sometimes n number of data are accessed. Okay, so at that time, if I am putting on lock and another same person is putting on lock, now there arises a dirty lock. Dirty lock means unwanted lock, or it might not be a appropriate one for locking systems. Okay, now we will see locking protocols. So how it is managed based on read and write. Right. So for read we have a Y. Okay, for read we have read and read we have Y. Read and write we have N. Write and read we have N, and write we have N. Okay, so now these are the locking managers where it locks on data items. So there are a different set of data. So each data will be gathered and locked by different data items. Now this locking managers use stored identity. Okay, so the lock manager actually uses its identity. So what is called identity? So where the permission is received and the identity of that particular transaction in a data item is made as a lock mode and a pointer. So what is the data item lock? Whether the pointer or lock mode will be in a simple way. If you are telling it, implement a lock table through a linked list. Okay, so you know what is called linked list. Based on the linked list, the locking status will be happened. Okay, so now here we are going to have managing the locks. We are managing the locks on different data items. Managing the locks between different data items. So the lock manager, what it is going to do? The lock manager stores the identity of the transaction and using lock mode and pointer. Okay, so next data item is locked means then that is called as linked list. Okay, next data will be locked means it will in the form of linked list. It is going to be locked, right? So that is called as locking protocol. This will also come in a MCQ. Just make a note. So what is called lock manager? What is called lock mode and pointer? Okay, and how the linked list is maintained in this locking. So these are the 4 possible questions which can be raised in this particular MCQ. Okay, so next, locking protocols. So there are different types of locking is there. So we will see the first one, that is primary and read write. Okay, so in read write we have a shared or exclusive lock also, which is inbuilt in the read write, right? Okay, so binary. So suppose you are going out of a house. Okay, your own house. So you want to lock the house for a security reason, but you have locked and went some distance, but then you have a confusion whether you are locked or not. So what do you do? Again you come back and check whether the lock is been done properly or not. Okay. If the lock is not done properly, then what you do? You will unlock the lock. Then you will check what is the problem, and again you lock the door. Okay. So already, if it is unlocked also, you will check that, and you will go to that particular option, and again you lock the home. Okay. So the door will be locked properly again. So that is the ultimate aim, locking the door properly. Okay. Now, so same way in this also we have a binary. Okay. So where 1 and 0 is implemented. So for the locking and the unlocking. Okay. So different locking, lock x equal to 1 previously it will be means, then the lock procedure will be in a 1 stage. Okay. So if it is a lock, based on this we have a lock and unlock, where we are going back and locking the unlocked, we're locking the door. Okay. So for this one we have another simple example, read write. So read write. So read write means whether it is if it is locked, then it will write. If not locked, it will write that stage also, read as well as write. So it has a shared or exclusive lock. Now some share mode lock will be there, where transaction TI will be shared on that particular lock, and you cannot write the X. So we are going to read the data item but cannot write. So mean the outer transaction will be due to the read the data item. So we can read the data item, but we cannot write. We cannot write the data item. Okay. So that is called as read lock. Only read we can do, and the write we cannot do. Okay. So that is share and exclusive. Right. So we'll have a small video session regarding this also. Just see that one, then you will get a clear idea. Again, we will continue the PPT. Okay.
Two-phase locking has the risk of deadlocks, so we need strategies for deadlock handling. To understand what deadlocks are, let's consider the following scenario. Let's say that we have transaction 1 obtains an exclusive lock on A. Now concurrently, transaction 2 obtains an exclusive lock on B. Now after some time, transaction 1 wants to obtain some lock on B. Shared or exclusive doesn't matter. This lock will be blocked because transaction 2 has an exclusive lock on B, so no other locks are allowed. Therefore, transaction 1 will have to wait until transaction 2 unlocks B. Now let's say that transaction 2 tries to obtain a lock on A. Again, it doesn't matter whether shared or exclusive, because transaction 1 holds an exclusive lock on A. This lock will be blocked. So transaction 2 is waiting for transaction 1 to unlock A. So both transactions now are stuck. Transaction 1 cannot progress. It waits for transaction 2. Transaction 2 cannot progress. It waits for transaction 1. Both wait for each other indefinitely. So we need the detection of deadlocks in order to resolve such situations. And the resolution is that one of the transactions must be aborted. One way to perform deadlock detection is via wait-for graphs. The nodes of this graph are the transactions that are currently running. And we have an edge from transaction 1 to transaction 2 if transaction 1 is blocked by the lock held by transaction 2. So the source of the error waits for the target of the error. So the system constructs this wait-for graph on the fly and periodically checks whether there are cycles in the graph. If there is a cycle, we have deadlock. And we resolve the deadlock by aborting one or more transactions on the cycle. However, this is not as easy as it sounds because the selection of the victim is challenging. If you're selecting young transactions, then this might lead to starvation. We might abort the same transactions over and over. If you're selecting old transactions for abortion, then we are throwing away a lot of computational investment. A simpler strategy for deadlock detection